Right, so this is a little bit of bits and pieces because I have a few questions myself, which you hopefully can discuss with me and contribute hopefully to a better understanding of this topic. Good, right, that was the wrong button. I first want to have a quick chat about a few published findings in myopia and in relation to oxygen saturation measurements in myopic eyes. Well, this is not an exhaustive literature review that I'm doing here, but just to get your minds jogging a little bit. So there are a couple of publications that looked into myopic eyes with diabetes. There's one study which I'm sure you're familiar with, looking into diabetic patients and their axial length and whether or not they have diabetic retinopathy or what stage of diabetic retinopathy. Turned out if you have longer eyes, you're less likely to have diabetic retinopathy. Now, same authors did another study looking at healthy individuals, measuring their axial length, also looking at oxygen saturation, calculating A minus V, and we all use different terminology, calling it oxygen consumption, oxygen extraction, A minus V saturation, so I hope you don't mind if I use one or the other here. And in parallel, they found reduced retinal function as measured by electrophysiology. So they used this study to also further explain their first findings, hypothesizing that if you have a longer eye, you have a less hypoxic environment, and that could partly explain, in their opinion, the lower risk of diabetic retinopathy in longer eyes. The reduction in oxygen consumption, they thought, could be partly attributed to change in photoreceptor density and change in morphology in the retina. There's also another study which just came out this year looking at high myopes and emmetropes. They did measure arteriolar venular oxygen saturation and A minus V ratio and found a reduced arterial oxygen saturation with increasing levels of myopia. Now, if you've read this article, you probably found as well that there was no description of the refractive error or axial length of those myopic eyes. I've had a quick chat with the authors, and their high myopes they defined as higher than -6 diopters. They didn't measure axial length and only measured the axial length in a few patients, so they couldn't relate it to axial length, but rather used the spherical mean equivalent. There's also another study which looked at high myopes or myopes with pathology and without pathology, but they measured vessel calibers and reactivity to flicker light. In those, they found that there wasn't a change in the reactivity, so in the dilation to flicker light exposure, in myopes with pathology or without compared to controls, but there was obviously smaller vessels, or the diameter of the vessel calibers were a lot smaller, which isn't a new finding, which we know from previous publications. Now, a couple of problems when we look at myopia as a topic with oxygen saturation, vessel diameters, and reactivity. There is a wide range of definitions and cutoff values. What do we call high myopia? What are we calling emmetropia? Then the question is, have we measured refractive error as a measure of myopia, or do we use axial length? There's also a problem which I came across, and maybe some of you can feedback on that to me, regarding imaging pigmentation levels, location, diameter, especially in regards to myopic patients and of different ethnic background. There's also in some studies the problem of the sample used, the age range, the ethnicity and comorbidities, because some of the patients included, for example, in the study of high myopes compared to emmetropes, which used oxygen saturation, the high myopes were a group between the years of 7 to 80, and unsurprisingly, the more problems were found with the higher age group. Now, so it's a question, how much did age contribute rather than sort of the longer eye. caliber measurements, often shown, but no information about have they been corrected for magnification or how have they been incorporated in the analysis. And then a big problem that we all have, we often look at isolated variables. We're only capable of measuring a small range. We can measure calibers, we can measure saturations, we might be able to do flow parameters, OCT variables, but not all studies measure all parameters, which then obviously gives only a limited picture. What's a sensible measure is also a question. When we look at studies showing that you have obviously seem to have a reduced risk of diabetic retinopathy in myopia, well, is that a major threat, or is it maculopathy, or is it glaucoma? So is it what should we sort of focus on? Why did we bother with myopes? There's a lot of evidence that myopia is a risk factor for open-angle glaucoma. There's also plenty of studies that have shown changes in glaucomatous patients when we measure them using oxygen saturation measurements and looking into the visual field damage. How can we link structural and functional changes? There seems to be evidence that there is a link between the two. Now, when we set out to measure those patients, we've had a wide look around how is the what are the oxygen consuming areas within the eye. And there are lots of different ones. I don't want to go into a great detail, but we have a lot of different tissues. We have a lot of different sort of supply for different areas within the eye. Some areas are vascularized, others aren't. So we have the choroid, we have the retinal vessels, we obviously have the vitreous, an avascular area, we have the lens, we have the anterior chamber, and at each of those levels we can't always directly measure the oxygen consumption or the oxygen present, but there is a couple of studies that have looked what happens to the partial oxygen pressure if you remove the vitreous, and the lens. And if we remove the vitreous, very often what you'll see is that you will develop a cataract very quickly. Why do we develop that cataract? Some hypotheses are that you have a higher exposure of oxygen to the lens, which is contributing to the cataract development. Now there is another nice study, I think the author is Siegfried, if I'm not wrong, which looked at partial oxygen pressure at different points within the eye in patients which still have their lenses and have their vitreous, in patients that had just a cataract removed, in patients that had only the vitreous removed, and in patients that have the cataract and the lens and the vitreous removed. It wasn't always a cataract. And measured also within the anterior chamber angle, behind the lens in the anterior chamber, in the posterior chamber, and found that there are quite some marked changes depending which parts you remove from the eyes. We also know from studies that taken out the vitreous and measured the oxygen saturation in the retinal circulation, that there is a higher venous saturation. Now, why did we think to find something, or that there could be a link between oxygen saturation and myopia or eye elongation? Well, basically there is an imbalance between all those tissues, or a structural change for sure. We have changes in vessel calibers. We obviously have other structural changes of layer thinning, stretching, morphological alterations, and they could all possibly have an effect on the oxygen delivery and blood flow within the eye. So what we thought could be that within individuals which have, I wanted to say what's the possible pathway that we think between sort of myopia and the glaucoma development, that in a stretched eye you could earlier develop a vitreous detachment, or the vitreous could naturally come off a little bit earlier or partially come off, and therefore your PO2 levels at the different points within the eye could change. Why could they change? Because other authors already hypothesized that if you have an intact vitreous which is fully attached, it's not just sort of part of providing the different pressure gradients, it also ensures that some of that oxygen delivered in the retinal circulation is pushed or helped to push back into the retinal tissue. Now, if you remove the vitreous or if it's come off naturally, there wouldn't be that barrier that ensures that it's sort of pushed back into the retina. If it therefore can sort of freely travel elsewhere, it could get more towards the anterior portion of the eye, not causing a massive step change in partial oxygen pressure, but it could be a very, very slow process that you have an imbalance, and therefore cause, similar to patients where you remove the lens and the vitreous, lead to an increased PO2 level in the anterior chamber angle and have a negative effect at the trabecular meshwork cells. Therefore, in a very slow way, contribute to the damage and therefore possibly contribute to glaucomatous developments. Now, there are other considerations. Vessel calibers, why are they just smaller because of the stretching? What is the effect of that? Also, another question that's come up is vessel density. Do we lose vessels, or are you at a disadvantage if you have a less complex vascular network? Some evidence points towards that the vessel density in glaucomatous eyes or in eyes with myopia is less than in emmetropic eyes or eyes that are healthy. Ocular volume could possibly also play a role. There isn't much information about on that, but if you have a larger tissue, that might also absorb more oxygen or consume more oxygen, which could have some effect on this too. Now, so a few bits and pieces. This is, I'm afraid, a little bit of piecemeal because nothing's truly finished yet. We've measured a lot of healthy young individuals. They're not all Caucasian. As a matter of fact, the majority is South Asian. 200 of them, 18 to 21 years old, so a very narrow age band. We didn't find any association between vessel density and axial length in that sample. And we've had a wide range of axial lengths there as well. So there wasn't any relationship. But of course, we found a significant relationship between axial length and vessel calibers. So the change in vessel density found in other studies might first come with age or with pathology. So when we looked in a slightly older group, but a lot smaller, we found a relationship of axial length with oxygen extraction, or with A-V saturation, and also relationship between fractal dimension, which we used as a measure of vessel density. Are you all familiar with fractal dimension? Silence? No? Never heard? Right. Quick explanation. If you take a picture of the retina and you're looking at the vessel tree, yeah, it does look like a little bit like an irregular structure. You can extract the information just off that vascular tree and convert it into a binary image. So you have a sort of black and white image of that vessel tree. And what is used to calculate fractal dimension is we use the box plotting technique. So basically you chop it up into ever smaller boxes and you extract the information whether the box is full, containing vessel, or it is empty. And out of that information you get a value which is called fractal dimension, which tells you a little bit how much vessel is there in your image if you want. So there's a range of software which you can use freely. One of it that we've used has been Image J and Neuron J and Fractalac. Those are all different plugins for it, and it's fairly straightforward. So we wanted to have a measure of how dense is sort of that, how many visible vessels or how much retinal vessels are in the area that we image. Now here are the sort of the pictures to the slide before. So in that slightly older sample, if you have sort of a more complex vessel structure, you seem to be able to have a higher A minus V ratio. So you seem to be able to extract more oxygen. And likewise, if you have a longer eye, you seem to have a lower A minus V extraction. But again, we've not seen that in that larger but much younger cohort. Bit further with the bits and pieces, fractal dimension in those healthy individuals showed a significant association with the diastolic blood pressure, unlike some other studies who found a significant association with systolic blood pressure. We thought that this could make sense because the diastolic blood pressure representing a little bit more of vascular resistance. So if you have a more complex network, you possibly have more resistance available. We've also looked at a selected group of cases because we haven't got a massive sample of those extremely high myopes yet, but all of them have axial lengths that are significantly longer than 26 millimeters. And the preliminary analysis showed that the majority has a venous saturation increase of between 80 up to 30% in some individuals. Now, they're all below the age of 45, so they're relatively young, but all of them have at least in one eye a mild cataract. So there are a few things that we thought fit very well with what we initially sort of wanted to look at. Now this is going to be my last slide. I didn't put much writing on here because this is an unfinished piece of work. We've got a relatively large sample of individuals, axial length, oxygen saturation, and a number of other parameters with various axial length. As you can see, the trouble that we had in terms of interpreting the results at the moment is it's a very mixed sample in terms of ethnic background and fundus pigmentation, both of which we think contribute quite a bit to the oxygen saturation calculations. We're using the Inedo system, which means my oximetry output, the saturation values have been corrected for vessel diameter and pigmentation. And the problematics that could happen there is that there is an assumption that this needs a diameter correction, which might not hold for myopic individuals and therefore mask any effect. The other problem is the changes in pigmentation. They could also contribute to that. So this is why I haven't put everything on. But what we do see, of course, is the longer your eye, the smaller your vessels get. But maybe the correction factors that we use for emetropic Caucasian individuals that have been used to calibrate it aren't really suitable. So, any suggestions? Or oppositions? Or anything else?
Can I just ask the obvious stupid question?
Yes, go ahead.
Very stupid. You said that
oh wait, we're told off in a second.
so the recording of before